Welcome to Ask an Expert. Hi, this is John Appleson, Marketing Manager with Pepperl+Fuchs. Today I'm joined by Tracy Molnar. Tracy works as an application engineer here at Pepperl+Fuchs. So welcome, Tracy, and thanks for being here.
Hi, John. Thanks for asking me.
The first question asks about the performance of the MB60 magnetic sensor when the sensing surface is less than 10 millimeters away. Tracy, the customer states that they had one unit show a spurious on, then off, and then on again when the sensing surface was about 3 millimeters away. The problem seemed to disappear when the sensor was pushed out to an 8 millimeter gap. Tracy, can you explain what's happening here?
Yes, the sensing range specifications on the MB60 sensor's datasheet are based on this sensor's use with a specific magnet. It's our DM60 magnet. And the size and strength of this, it activates the sensor when the gap is between 10 and 50 millimeters. So if the magnet's closer or if it's farther away, the sensor's output may not be predictable, as the customer has discovered. That's why the 10 to 50 millimeter range is shown on the datasheet. Magnetic sensors also won't signal detection where the poles meet on a magnet. But if the customer uses a different magnet with the MB sensor, the MB60 sensor, and a magnet that's smaller or weaker than the DM60, he'll see a reduction in that uncertain part of the range when approaching either pole of the magnet. In fact, I've tested this sensor with a variety of magnet targets and found some for which the output stays on even if the target and sensor are touching. But we don't have any data that will allow us to predict the sensor's response based on size or strength of the magnetic field target. That's something that needs to be determined in the application, like the customer's doing.
Okay, this customer wants to know how the 41FY1 works and if it's a two-part magnetic sensor.
Well, first of all, 41FY1 is not the sensor, it's the magnet target that serves as a matching actuator for magnetic field sensors in the 40FY series. The sensor and magnet are in identical housings, except the sensor includes a cable for the purpose of electrical connection. So yes, this is a two-part device consisting of the sensor and a matching magnet. 40FY sensors and other similar devices require power, both to generate the detection field they emit and to produce their solid-state switching output. When powered, and in the case of two-wire devices with an appropriate load in series, an electromagnetic field is generated from the sensing face, and when the target magnet enters this field, the sensor's output switches states. So that's how they work.
So we have a customer who is wondering what the required target size is for the NJ5 18GM inductive sensor. And if a keyway that is 1/8 inch wide and 30 thousandths deep on a 4-inch diameter shaft would work, can you share your thoughts on this?
Sure, the customer's sensor is an inductive sensor, so it's activated by metal entering its detection field. And based on the customer's description, the 4-inch shaft, assuming it's made of metal, would be the actual target for the sensor. The keyway would then be a place where you might want the sensor's output to switch, signaling the absence of a target. Except such a small area would not be large enough for this sensor, which has a detection area as wide as its 18 millimeter sensing face at a very short range, and doesn't get as small as 1/8 of an inch until nearly the far end of its range. Even if you were to manage to set the sensor at a place where the output would switch at the 1/8 inch keyway, as soon as the shaft was rotating with any speed, that small gap in the metal target would pass by too quickly for the sensor to switch there. The general recommendation for such an application is to have the target be at least as large as the sensing face, so 18 millimeters in diameter in this case, and for any spaces between targets to be twice that size, which would be 36 millimeters in diameter, and that equates to a nearly 1.5 inch wide keyway. In addition, that keyway would need to be much deeper than the 30 thousandths this customer proposes, in order to ensure that the metal that remains in the gap does not influence the sensor's operation. In this case, the keyway should be at least 15 millimeters deep, which is about 6/10 of an inch.
All right, in this next application, the customer has an EO-type output inductive sensor that's connected to a PLC, but he can't seem to get them to work together. He states that when he's testing with a 24 volt supply and a voltmeter, he's able to read about 22 volts from the output, the black wire. However, when he's connected to the PLC, which is a 24 volt system, the PLC input's not activating. What do you think the problem is?
Well, since the sensor operates correctly when tested with a voltmeter on a bench, the problem most likely has to do with the wiring to the PLC input card. The voltage difference, 24 and 22, is probably not going to matter to the PLC, but because the sensor is an E0 type, that's a 3-wire device with NPN or current sinking output. And that means that the switching output on the sensor's third wire, the black wire, is internally pulled down to DC negative and needs an external source, typically the 24-volt DC, at his PLC input. But if the customer's input card provides a current sink instead, the DC negative, instead of a source, then this sensor won't work with it, and he'll need to switch to a sensor that has PNP or current sourcing output. Those are the E2 types.
Okay, last question, Tracy. This customer is using one of our quick disconnect sensors on a valve assembly, but he has very specific requirements for the cable that he wants to use. Does he have to use one of our standard core sets, or are there other alternatives?
We have a variety of cord sets available for use with our sensors, but there are times when exactly what the customer wants is not available. In a case like this, we do have an alternative for wiring the sensor. The customer can find a raw cable that meets his particular requirements and make his own cord set using one of the field attachable connectors we offer.
Well, that concludes this segment of Ask an Expert. I want to thank Tracy for joining me today and thank our audience as well. For additional information, here are 5 easy ways to connect with us.